your way to your seats, we'll get started here with our afternoon session. So talking next is Jeff Tyson from the Great Lakes Fishery Commission, and he's going to be talking to us about spawning whitefish and the invasive mussel swim. So an update on those programs. Thanks, Jeff.
Thank you, Becky and the Lake Michigan Committee, for allowing me an opportunity to present an update on the spawning whitefish and an invasive mussel project, the SWIM project. And first I'd like to thank the SWIM team because they provided all this information. I'm just the front man, and they're the experts on this. This photograph right here shows an image from the Mid-Lake Reef Complex and the impacts that invasive mussels are having on the structural habitat in that location and in many locations across the Great Lakes Basin. The SWIM project is essentially a 5-year project to implement invasive mussel control at a couple of locations in the Great Lakes, one in Lake Michigan and one in Lake Huron. And we've got really 2 objectives. The first one is to build on some previous successes in Lake Michigan at Good Harbor Reef, small-scale control effort that occurred back in 2019, and then at various points since then as well. And then the second objective is to assess whether localized but larger scale than that small-scale experiment that occurred in 2019, mussel control on a spawning reef can improve lake whitefish production by improving embryo survival. So we're focusing on the early life history components here. A little bit of a background on the timeline for the project. Back in 2022, the federal leads for the SWIM team contacted the Lake Michigan Committee, Lake Huron Committee, and Invasive Mussel Collaborative, requesting support for implementing experimental mussel control. We convened a number of meetings with fisheries technical experts and the IMC to help with identifying sort of specific locations where experimental mussel control could occur and define the scope of sort of an experimental control project. 2023, the experimental design was developed and sites were identified based on the feedback from the lake committees as well as the tech committees, and then funding was sought. So in 2024 was the first year of this 5-year project, and we began with sort of the pre-site assessment work at 2 locations in the Great Lakes, and additionally we conducted outreach with a number of folks as well as developed some communication tools. And then 2025 will be the second year. So this is a 5-year experimental control project, with the first 2 years being pre-site assessment, the third year being the big E, experimental control, and then years 4 and 5 being post-site assessment. Two sites were chosen after evaluating about 170 potential locations across the basin. The Lake Michigan site is Good Harbor Reef, a very large reef complex in Lake Michigan. Lots of experimental work has occurred at this location in the past. And then Thunder Bay Reefs, which is a smaller man-made reef complex on the eastern side of Michigan in Lake Huron that has a fairly significant assessment that's been conducted in the past at those locations as well. But these are 2 really different kind of reef complexes, if you will. A little background on the experimental design. It's a before-after control impact design. Like I said, 2 reefs that vary in size and characteristics and exposure. At each complex, we'll have a treatment site as well as a control site or a reference site, and we're doing 2 years of pre-assessment at each of these sites. Big E experimental control in year 3, and then 2 years of post-assessment. We've used some power analysis from some of the previous work that's been done at these sites to help inform sort of what level of effect we might expect relative to lake whitefish egg survival. This is just a little more information on what we're expecting, and from a treatment size standpoint, up to about 3,000 meters likely will be treated at Good Harbor Reef, but I've got some additional points later in in the presentation that we'll come back to this on. And then about 450 cubic or square meters at Thunder Bay. The methods that are being developed and scaled up include benthic mats with carbon dioxide injected underneath as well. This is the structure of the SWIM team, if you will. There's a core federal team comprised of representatives from US EPA, USGS, NOAA, National Park Service, US Fish and Wildlife Service, BIA, and then also supported by the Great Lakes Fishery Commission and the Great Lakes Commission. The core planning team includes that core federal team as well as implementation leads. We've got 5 implementation teams, including a mussel control team that's led by Diane Waller and Harvey Bootsma, a spawning team that's looking at adult behavior led by Daryl Hondor and Tyler Funnell, egg deposition and embryo survival team that's led by Ben Tershak and Ellen Marsden, and then a Cladophora benthic nutrients team led by Marianne Evans, habitat mapping goby and mussel density team led by Pete Esselman. So I'm going to give you a brief update on the activities from 2024. The Cladophora and benthic nutrient team were measuring a whole host of parameters on each of these reef sites. I'm not going to get into each one of these, but obviously the key ones are water quality related, dracaenid mussel related, and then benthic algae. One of the value added pieces with this team is they do have some more video cameras at each of those locations to help sort of visualize what's going on, and they're also using some eDNA to look at fish community composition. This shows sort of a high-level summary of results from the 2024 work for each of the reefs, the Good Harbor on top and Thunder Bay reefs at the bottom. They are different. Good Harbor Reef is primarily boulder cobble, really high levels of infilling with zebra mussel or dracaenid mussel shell hash and gravel, while the constructed reefs at Thunder Bay generally have more interstitial spaces and are primarily cobble. The dracaenid coverage at both of these sites is a little bit different. Complete coverage at the Good Harbor Reef site, while most of the coverage at Thunder Bay is on the sides, bottoms of rocks, and in the interstitial spaces. One of the things that the team found is that there was complete benthic algal coverage at both of these sites in July when they assessed, and primarily Cladophora, but other filamentous algae as well. And then they went back out in October and still had about 80% coverage of benthic algae at these 2 locations, which is, they were out probably a couple of months before Lake Whitefish spawning would have occurred. And this image just shows quadrats, and on the top, Good Harbor Reef, and the bottom, Thunder Bay Reef. So you can see the differences in the characteristics of these 2 sites. Next, update on the habitat mapping goby and mussel density implementation team. Their objectives are to provide high-resolution maps of the physical habitat at the 2 locations, and then estimate living and dead mussels, round gobies, and other egg predators at these 2 locations. Using multi-beam sonar, and Matt talked a little bit about that in the habitat presentation, some of the equipment as well as the data that was collected in the Northern Lake Michigan Reef Assessment Project is being incorporated into this experimental mussel control project. So high-resolution bathymetry, as well as deploying autonomous vehicles to collect photo images for validation of the information. Also using AI to help process images and estimate goby density, as well as zebra and quagga mussel density and coverage. So these are some images from the AUV. On the top left, you've got images of the substrate characterization, goby detection image here, dracaenid coverage here that they're using AI to estimate, and then they're also using some other tools to try to estimate interstitial spaces. Lots of work occurred in 2024 at both of these sites using both the multi-beam sonar as well as the autonomous underwater vehicles, characterizing not only specific locations, but also some locations in Thunder Bay that are associated with a natural reef there. Next, an update on the spawning implementation team. Activities in 2024. Don't want to spend too much time on this because most of you probably are familiar with acoustic telemetry. Fish were collected at both Thunder Bay Reef and Good Harbor Reef during the fall using gill nets and trap nets. Acoustic tags were implanted into the fish. These acoustic tags have 3-year life cycle or battery life, and then pressure and temperature tags as well. And those fish were released on site. This slide just shows the distribution of the acoustic receivers at both Thunder Bay on the top and Good Harbor Reef on the bottom. These are VPS arrays, so we get position, location information on fish as they're utilizing those during the spawning season. And this is just a little pre-data for Good Harbor Reef because there was a lot of pre-information that was already in hand there. This shows distribution of lake whitefish during the spawning season across that reef, and the red areas essentially are hotspots, activity hotspots where presumed spawning is occurring. Because the reef is so big, this was invaluable for sort of siting the experimental control work. So moving forward, the intent is to deploy egg traps and larval emergence traps in those locations. So moving on to the egg deposition and embryo survival implementation team for Thunder Bay in the fall of 2024. 2 gangs of 10 egg traps were deployed on each line of these artificial reefs here, the CEM line and the CKD line, and you can see where those egg traps were deployed. And then this spring, so I presume right now or soon thereafter, larval emergence traps are going to be deployed at that location. This is some of the data from 2024. Unfortunately, there's historic data at Thunder Bay Reef Complex as well that shows along the x-axis year, along the y-axis egg density in meters per, or number per meter squared. And you can see that generally in the 2010 to 2013 time period, there was higher egg densities, lake whitefish egg densities. At this location, 2024, still has a fair number of eggs, but it's lower than what it was, and that's presumed to be associated with declines in lake whitefish since the work that was conducted back in 2010 to 2013. Additionally, the cladophora team, like I said, deployed video cameras at this location and did document lake whitefish spawning on those cameras. So next, let's move on to the Good Harbor Reef egg deposition work that occurred in 2024. Egg traps were deployed at 3 sites on Good Harbor Reef in that hot spot that I showed you from the acoustic telemetry slide. We had a control site where essentially no mussel removal will occur. We have a removal site here, and then there was also a gear comparison site that was deployed, or traps were deployed at. Generally, 40 traps at each experimental site and the comparison site, very low egg densities. So egg densities less than 5 per meter squared, an average of 0.75 eggs per gang. At the comparison site, the reason the implementation team deployed traps at this location is that historically samples from Good Harbor Reef have been collected with egg mats. So they wanted to get a comparison between the egg mats that were historically used and these egg traps that were deployed in 2014. The upside is that egg mats and egg traps generally collected similar densities of eggs. The downside is they both collected less than 5 eggs per meter squared. So we do have historical information from Good Harbor Reef, thanks to the Northern Lake Michigan Reef Assessment Team and Michigan DNR TNC and partners. And this slide shows the egg density, lake whitefish egg density across time. And you can see that generally egg densities are low. What we were hoping is with the focus from the acoustic telemetry that putting these in a specific location, we'd have higher egg densities. And unfortunately, egg densities were still relatively low for both the mats and the traps. So that's got the swim team thinking about potential alternatives moving forward. And again, thanks to the Northern Lake Michigan Reef Assessment Project, there were egg density estimates from other locations across the basin. and right here shows these various sites across the basin with egg density. And you can see that Good Harbor Reef is right down here with essentially very few eggs, but there are a number of other locations that do have higher egg density that would allow for detecting an effect associated with mussel control. So right now, the team is thinking about exploring another site, in particular Wiggins Point, which is up here on the northwest side of Lake Michigan, has relatively high egg densities, and I believe they're out right now looking at larval emergence just to try to confirm whether that's a viable site or not. And then lastly, the mussel control implementation team implemented a pilot project on Loon Lake in northwestern Michigan. They looked at various control methods, including benthic mats, polyvinyl, and heavy black plastic, deployed over a series of days from 10 to 30, and then also looked at carbon dioxide under a mat for a 5-day period, measured dissolved oxygen, pH, mussel mortality, as well as benthos diversity and abundance. Results from that 2024 work suggested that none of the mats had 100% mussel mortality, but the vinyl mats were more effective than the black plastic. These are the vinyl mats over here. The black plastic, while there's some variability, were less effective. The CO2 treatment, however, is promising. There was about 94% mortality at the pilot site, and the benthos impacts between both of those two control methods was very similar. So in 2025, the control team is looking to test some other materials, dimensions, work on scaling up deployment and retrieval methods, and then investigating additional benthos recolonization. So really, in summary, year one of the before sampling was completed by all the implementation teams. Like I said before, the egg density, egg larval survival team has some concerns about low egg density on Good Harbor Reef, exploring potential opportunities at Wiggins Point up in northwestern Lake Michigan. Mussel control pilot work was completed in 2024, and the benthic mat plus CO2 seems promising, but we need to do some work for scaling up, and that's going to happen this year on Good Harbor Reef. And then the first embryo emergence data is currently being collected at both Good Harbor Reef as well as Thunder Bay Reef and Wiggins Point Reef as well. We've done a fair bit of outreach over the past year associated with the project. There's a website that's been developed that has additional information, and we have been currently engaged with tribal engagement as well. So with that, I would like to first thank the Lake Michigan Lake Huron Committee's Invasive Mussel Collaborative for supporting moving forward on this project. I would like to thank the implementation team and the swim team as a whole, because they're the ones that provided this information. I'm just the front man. And I'll take any questions that I can try to take. And if I can't, I'll refer you to the most appropriate person.